Hey, this is Mr. James. In this video, we're going to be talking about the area and perimeter of a circle. To start, we'll talk about the circumference and the area of an entire circle, and then later we'll talk about the arc length and sector of just part of a circle. So to start, circumference and area. You might remember from middle school that circumference is the length or the distance along the outside edge of a circle, just like that, all the way around. Now the circumference depends on the radius of the circle. So circumference could equal 2 times pi times the radius of a circle, 2 pi r. Or it could equal pi times the diameter, pi d. This makes sense because 2 radii are equal to 1 diameter. So you can use either of those two formulas. On the other hand, area, well, that's just the two-dimensional space on the inside of a circle like that. And area also depends on the radius of a circle. The formula for area of a circle is pi r squared. At this point, I'm going to go ahead and find the circumference and area of circle 1. When I'm done, you can pause the video and try and find the circumference and area of circles 2 and 3 by yourself. So, first, number 1. Remember, circumference is either 2 pi r or it is pi times the diameter. Okay, in this case I'm given the diameter, so I might as well work with the second one. So circumference in this case will be pi times 22. At this point you have two options. You could either write your answer in exact form, or you can write it in decimal form. Okay, the difference is that, remember, pi, the number pi, is 3.14159, and it keeps going forever, right? It's got an infinite number of digits to it. And so whenever we multiply something by 3.14, we're actually just rounding. We're using a decimal number and we're rounding. So in exact form, we never multiply by pi. We just leave the pi symbol there. So this in exact form would be 22 pi. We don't multiply by pi, we just stick it on the end. However, in decimal form, we do multiply 22 by 3.14, and we get 69.08. It's important to keep in mind that the units for these are miles, because, remember, the original length was in miles. Now for the area, the formula for area is pi r squared. Now, the diameter over here was 22 miles, so the radius will be 11 miles. 11 miles. And so when I plug everything in, I get pi times 11 squared, which ends up being pi times 121. And now, exact form, right? I'm not going to multiply by pi, because that would give me a decimal. And I'd be left with 121 pi. Or, if I want to be an exact form, I would do 121 times 3.14, and I would get 379.94. Now remember, the units for these are going to be miles squared. Miles squared. Or, also known as square miles. Square miles. Now remember, area is always in units squared, and circumference is always in just the regular units. The reason is because circumference is a length, it's a distance. And area, well, area is, I guess, the amount of space that something takes up in 2 dimensions. So because of that, we write these units in square miles. Go ahead, pause the video here, and try 2 and 3. Alright, so here we go with problems 2 and 3. Problem 2, find the circumference. Well, let's see. The diameter is 4 centimeters, so I'm going to have the circumference be pi times 4 centimeters. And so in exact form, that would be 4 pi centimeters. And in decimal form, if I multiply 4 by 3.14, I end up with 12.56 centimeters. On the other hand, for the area, let's see, area is pi r squared, so remember my radius here will be 2, so it's pi times 2 squared. And so in exact form, that ends up being 4 pi. And if I multiply 4 by 3.14, I end up with 12.56. Remember that those are in centimeters squared, or square centimeters. Centimeters squared. And for number 3, well, look at this. Number 3, the radius is 11, so the diameter would be 22. And this is actually the same exact problem as number 1. So just like number 1, I've got my circumference is pi times 22. In exact form, that is 22 pi miles. In decimal form, that is 69.08 miles. The area, again, is going to be pi 11 squared. So in exact form, that ends up being 121 pi. And in decimal form, that ends up being 379.94. Remember, those are both in miles squared. Miles squared. So we talked about the circumference and the area of a full circle, but what if I want to know the circumference and area of just part of a circle? Well, part of a circle, just like this kind of wedge, is called a sector. Those are two sectors. And we're going to try and find what the length of just a sector is and what the area of a sector is. So first, let's look at some easier sectors, and then we'll come back to the general case. Now, halfway down the page, we've got semicircle and quadrant. Remember that a semicircle is just half of a circle, 180 degrees of that circle, and a quadrant is a quarter of the circle, or 90 degrees of that circle. Now we're going to answer this question right here. Find the arc length of a semicircle with a radius of 11. But before we do, let's talk about how to find the circumference of an entire circle with a radius of 11. We'll use this as our example. So if I have a radius of 11, okay, how do I find the circumference? Well, the circumference is pi times the diameter. The diameter of this is going to be 22, so my circumference is 22 pi. But let's come back to this question. Let's say I just wanted half of that circle, right? I wouldn't want 22 pi. I just want to know the distance from here to here, half that circle. Well, it would make sense that it was 11 pi. I would take the regular circumference, 22 pi, okay, and multiply it by half. Half of 22 is 11, or 11 pi. What about if I had only a quadrant? Again, I've got a radius of 11, so the whole circumference is going to be 22 pi. But now, I only want a quarter of the circle. So it makes sense that I would take my 22 pi, I'll multiply this time by a quarter of the 22 pi. And what's a quarter of 22? Well, I guess it could be 5.5 pi, or you could write it as 11 pi over 2 if you don't want to reduce your fraction. But we're taking a quarter of that circle. Now you can start to see that to find the arc length of just part of a circle, all you do is you take a fraction of the original circle. Let's go back up to the top for a second. The circumference or area of a full circle has 360 degrees in it. That's the total number of degrees in a circle. So if we just wanted to find a smaller part of that circle, maybe say 20 degrees or 30 degrees or 60 degrees or 100 degrees, what we would do is take the original circumference, which is pi times the diameter, and we'd multiply it by the number of degrees that we're looking at out of 360. The same thing is going to happen for a sector. We take our original area, which is pi r squared, and we're going to multiply that by a fraction. How many degrees in that sector? Out of 360. Let me give you an example down at the bottom of the page. So I'll do number 4 for you, and then you can pause the video and try 5 and 6. So for number 4, we're going to find the length of this arc right here, and we're going to find the area of this sector right there. Now to start to find the length of the arc, we're going to try and find the length of the entire circumference. So the length of the circumference, remember, is pi times the diameter. In this case, the diameter is 22. So pi times 22. However, I don't want the entire circumference. I only want this part, this 90 degrees out of the total 360. So what I'm going to do is at the front, I'll write 90 over 360. Now, when we're simplifying this, we want to multiply all the numbers on the top of the fraction together and leave the numbers on the bottom of the fraction like that. So let's see, 90 times 22 gets me 1980. Right, we're not going to multiply by pi. We have to leave that for exact form. On the bottom, we've got 360. Okay, and then if we simplify that, we end up with, let's see, 11 pi over 2. That's our answer, 11 pi over 2. Now you could put that in the calculator to get it in decimal form, but we're going to leave things in exact form for now. The area of the sector is very similar. We start by writing the area of the entire circle, which is, remember, pi r squared. So pi 11 squared. But we don't want the entire circle. We just want the area of these 90 degrees of the circle. So we put 90 over 360 out front. Let's see. We have 90 times 11 squared. So let's see. That's 90 times 121, or it's a big number, 10,890 pi, or we're not going to multiply by pi, over 360. And if we simplify this, we get 121 pi over 4. And again, you could put this in the calculator and get a decimal, but we're going to leave it in exact form for now. At this point, you can go ahead, pause the video, and try doing 5 and 6. When you're done, unpause the video, and I'll run through them. All right, let's tackle 5 and 6. For 5, I'm trying to find the arc length of just the 60 degrees of that circle. So, to start, we write the circumference, which would be pi times 6, because the diameter here would be 6. But we don't want the entire diameter, the entire circumference. We just want 60 degrees of it. So I'll put 60 over 360. Now, if we multiply the top together, we get 360 pi over 360. And if we simplify that, we get just pi. So this length right here is just pi, or 3.14 miles long. Okay. For the area of the sector, it's pretty similar. We start with the area of the whole circle, which would be, let's see, pi r squared, pi times 3 squared. But we only want 60 of the 360 degrees, so we put that out front. If you simplify that, you should end up with 540 pi over 360. And if you simplify that one, you should end up with 3 pi over 2. And that is where we'll leave it in exact form. Again, this would be in miles squared, because this is area, and the first one would be in just miles, because it's just length. Again, this would be yards, this would be yards squared. Okay, and then for number 6, let's see. Wow, we've got a really big arc right there. So that'll be 225 over 360 degrees times pi times, well, the radius is 10, so the diameter is going to be 20 times 20. And if you simplify that all down, you should get 25 pi over 2. For the area, well, remember we'll have 225 out of the 360 degrees times pi times the radius squared. And if you simplify that down, you should end up with 125 pi over 2. And again, this is in inches, and this is in inches squared. Okay, there you have it. There is 5 and 6. At this point, we've talked about circumference and area of the whole circle, and arc length and sector are just part of the circle. Remember, they're very related. The only difference between circumference and arc length and area and a sector is just that we're multiplying the formulas by the number of degrees of the arc over 360 in the front of the formula.